the energy of an electron in hydrogen atom in the ground state works out to be minus 2.1 into 10 to the power minus 18 joule per atom. That is, this is the energy of the ground state, that is where n is equal to 1, the energy is equal to minus 2.18 into 10 to the power minus 18 joule per atom. Now, what is the question given to you is, calculate what will happen to the position of the electrons in this atom if the energy of 1.938 into 10 to the power minus 18 joule is applied. That is, this much energy you are giving from the outside. Now what do you require? How much energy is it going to absorb, or what will be the energy of that electron in the next orbital? You need to calculate the position. How can you calculate the position? We can calculate it by that the energy in nth orbit is equal to the energy in the ground state upon n square. Now we don't know this energy in the nth orbit here. We just know that this much amount of energy, that is 1.938 into 10 to the power minus 18, is supplied from outside. But how much energy it has absorbed and what particular energy it is possessing at that orbital to which it has raised. So if I just draw the diagram of this atom, say this is your hydrogen atom. Now in this there is a nucleus at the center and we have got one energy level. Now the electron has got what energy at this level? It has how much energy? It has minus 2.18 into 10 to the power minus 18 joule. Now it is absorbing energy. How much energy it is absorbing? It is absorbing how much energy? That is 1.938 into 10 to the power minus 18 joule. And what it is doing? It is raising to a higher energy level. And we don't know that energy level. So there will be some specific energy which this electron will be having. How can we find out? We can just find out by subtracting the two. So that is, the energy of electron in nth orbit will be equal to this energy, that is the ground state energy, into 10 to the power minus 18 minus how much energy we are providing from the outside, that is 1.938, plus these are providing from the outside, and it would be into 10 to the power minus 18. So how much we are going to get? This electron is having how much energy? It would be, let's calculate, it is 2.18 minus 1.938, and that comes out to be 0.242. This energy is positive because we are providing it from the outside. So this comes out to be minus 0.242 into 10 to the power minus 18. Now students, this much energy is present in the electron when it is in nth orbit. Now can we find out what is that orbit? En we have got, that is minus 0.242 into 10 to the power minus 18. I'll write minus correctly so that you're not getting confused here. It would be minus 0.242. Okay. Now this is equal to the energy at the first orbit, that is minus 2.18 into 10 to the power minus 18, and that is divided by n square. Now what is this n square? N is the number of the orbit. So what would your n equal to? N square will be equal to, I think you know this much of maths, you just divide it. I am getting 9 here, and your n would be equal to 3. That is, to which orbital your electron has jumped? The electron has jumped to 3rd orbital. That is, it has moved from n is equal to 1 to n is equal to 3. That is the 3rd orbital.